Good morning, everyone. Welcome back to our Valenzuela Facebook live streaming for Mathematics 9. Right now, we'll be discussing the 6 trigonometric ratios. Make sure you have your learning packets with you, your notebook, and a pen for taking down notes. You may also use the chat box to key in your answers to the questions that I will be giving throughout the discussion. So let's start. Great. For today's objectives, you must be able to define trigonometric ratios and illustrate the 6 trigonometric ratios, which are sine, cosine, tangent, secant, cosecant, and cotangent. It is very important that you have knowledge in right triangle to fully understand the concept of the trigonometric ratios. With this, let's review on the parts of the right triangle, which are the hypotenuse, the adjacent side, and the opposite side. Let's have a pick a card activity. I have here 4 cards. Choose among the cards here and answer the question behind it. We have blue, red, yellow, and pink. For each question answered, there will appear a piece of the whole picture for me to introduce to you after this activity. To answer, click the reaction that corresponds to your answer. You may click like, heart, or care reaction. Are you ready? Let's begin. Kindly type your chosen card to be answered. Okay, you have different answers here, but majority of you chose red card. Here is the question. Given triangle TIE, what is the side opposite to angle T? Click like if your answer is segment TE. Click heart reaction if your answer is segment IT. And care reaction if your answer is segment EI. You have 5 seconds to answer. Go! Time is up. If you click care reaction, then you are correct. Given the figure, triangle TIE, you were asked to find the opposite side of angle P. If this is angle P, the side across the given angle is segment EI, which is considered as the opposite angle. Let's go back to the set of cards. We are done with red card, and let's reveal the piece of picture. Next, type your chosen card in our chat box. Alright, let's have the blue card. Here is the question. What is the hypotenuse of triangle GEP? Click like reaction if your answer is segment GE. Heart reaction if your answer is segment GE, and care reaction if your answer is segment ET. You have 5 seconds to answer. Go! Time is up. If you click like reaction, then you are correct. Given the triangle GEP, angle E is a right angle, and the side opposite to it is called hypotenuse. And this is considered as the longest side of a triangle. With this, segment GT is the side opposite to it, and it is considered as the hypotenuse of triangle GEP. t. We are nearly completing the whole picture. Okay? Next, let's have the pink card. Okay? Given triangle CAR, what is the side opposite of angle R? Click like reaction if your answer is segment CA. Heart reaction if your answer is segment AR. And care reaction if your answer is segment RC. You have 5 seconds to answer. Go. Time is up. The answer is segment CA. So, if you click the like reaction, then you are correct. Given the triangle CAR, considering that this is our angle R, the side across the given angle is segment CA, which is considered as the opposite
side.
Here is the picture behind the card. And we still have one left. I hope you already know him. For the last card, here is the question. Given triangle MAP, what is the non-hypotenuse side that is next to angle T? Click like reaction if your answer is segment MP. Heart reaction if your answer is segment AP. And care reaction if your answer is segment MA. 5 seconds to answer. Go. Time is up. If you click heart reaction, then you are correct. Given triangle MAT, considering this angle T, the two sides next to it are segment MP and segment AP. As you observed, MP is a hypotenuse, while AP is the leg of the triangle. And consider as the non-hypotenuse side of the given triangle next to angle T. And this is non-hypotenuse side, which is the adjacent side of angle T. Excellent. Here is the picture behind the yellow part. We have now completed the picture. Do you know him? Right. He is Hipparchus. He is the father of trigonometry. He developed trigonometry and constructed trigonometric tables based on the chord in a circle. And he solved several problems of spherical trigonometry. He also introduced the division of a circle into 360 degrees. As defined, trigonometry is the branch of mathematics dealing with the relations of the sides and angles of triangles, and with the relevant functions of any angles. There are 6 trigonometric ratios, which are the following. The sine theta is equal to the ratio of length of opposite side to length of hypotenuse, and it is abbreviated as sin. Cosine theta is equal to the length of adjacent side to the length of hypotenuse, and it is abbreviated as cos. Tangent theta is equal to the ratio of the length of opposite side to length of adjacent side, and it is abbreviated as tan. Next, cosecant theta is equal to the ratio of the length of hypotenuse to length of opposite side. And it is abbreviated as CSC. Secant theta is equal to the ratio of the length of hypotenuse to length of adjacent side. And it is abbreviated as sec. Lastly, cotangent theta is equal to the ratio of the length of adjacent side to the length of opposite side, and it is abbreviated as cot. The ratios of corresponding sides of two adjacent right triangles are equivalent if the acute angle of one right triangle is equal to the acute angle of another right triangle. The trigonometric ratios are the ratios between the two sides of a right triangle. Note that the value of the trigonometric ratio depends only on the measure of the acute angle of a right triangle. Let's say we have triangle HOT. Let's label the parts of this right triangle because we'll be using this in our trigonometric ratios. We have angle O as the right angle, and let's use angle T as our basis in determining the parts of the triangle. Angle T is one of the acute angles in triangle HOT. The longest side and the side opposite the angle O, which is the right angle, is called the hypotenuse. Therefore, segment HT is the hypotenuse of triangle HOT. Next, with respect to angle T, the side next to it, which is not a hypotenuse, is segment OT. And this is the adjacent side of triangle HOT. Always remember that adjacent side is the non-hypotenuse side that is next to a given angle. Lastly, with respect to angle T also, the side across from the given angle, which is angle T, is what we call as the opposite side. So, segment HO is the opposite side of triangle HOT. Did you understand? May I have a like reaction if you did? Alright. Given that we have triangle HOT, let's now discuss the 6 trigonometric ratios. Always remember that you need to identify the lengths of a hypotenuse, opposite side, and the adjacent side of the given triangle for you to get the trigonometric ratios correctly. Let's start with the sine. It is the ratio between the lengths of opposite side of the given angle and the hypotenuse. That's why we have sine T is equal to the length of opposite side, which can be represented as O over the length of hypotenuse, which can be represented as H. Next, cosine is the ratio between the lengths of adjacent side of the given angle and the hypotenuse. Therefore, we have cosine T is equal to the length of the adjacent side of the given angle, which can be represented as A, over the hypotenuse, which can be represented by H. Let's now have the tangent. It is the ratio between the lengths of the opposite side and the length of the adjacent side of the given angle. Hence, we have Tangent T is equal to the length of opposite side, which can be represented as O, over the length of the adjacent side, which can be represented as A. With this concept, the mnemonic SOHCAHTOA used for us to easily remember the trigonometric ratios. From SO, S stands for sine, O stands for opposite side, and H stands for hypotenuse. So that sine theta is equal to opposite side over the hypotenuse. Moreover, C stands for cosine, A stands for adjacent side, and H stands for hypotenuse. This cosine theta is equal to adjacent side over the hypotenuse side. Next is TOA. T stands for tangent, O stands for opposite side, and A stands for adjacent side. This tangent theta is equal to opposite side over adjacent side. On the other hand, we have the mnemonic COSHCAHTOA as the reciprocal ratio of SOHCAHTOA. Co is the reciprocal of sine ratio. So C stands for cosecant. H stands for hypotenuse. And O stands for opposite side. That is why we have cosecant T is equal to hypotenuse over opposite side. In other words, cosecant is the reciprocal of sine. SHA is the reciprocal of cosine ratio. S stands for secant, H stands for hypotenuse, and A stands for adjacent side. That is why we have secant T. Secant T is equal to hypotenuse over adjacent side. Remember that secant is the reciprocal of cosine. Cow is the reciprocal of tangent. C stands for cotangent. A stands for adjacent. And O stands for opposite side. That is why we have cotangent T is equal to adjacent side over opposite side. Cotangent is the reciprocal of tangent. Again, remember the mnemonic SOHCAHTOA and COSHCAHTOA in determining the 6 trigonometric ratios. Let's apply this using our examples. Example number 1, find the 6 trigonometric ratios with respect to angle R of the given triangle RED. First, let's identify the length of sides of the right triangle. What is the length of hypotenuse? Perfect. It is 41 centimeters. How about the length of opposite side with respect to angle R? Yes, it is 40 centimeters. What is the length of adjacent side with respect to angle R? Exactly, it is 9 centimeters. Now, let's get the trigonometric ratios. For sine R, we have opposite side over hypotenuse. Opposite side is equal to 40 and hypotenuse is equal to 41. We have 40 over 41. Cosine R, we have adjacent side over the hypotenuse. Adjacent side is equal to 9 and hypotenuse is equal to 41. We have the ratio 9 over 41 for cosine R. Tangent R, we have the opposite side over the adjacent side. Opposite side is equal to 40 and adjacent side is equal to 9. we have 40 over 9. To get the cosecant of angle R, just get the reciprocal of sine ratio. It will be 41 over 40. Next, to get the secant R, just get the reciprocal of cosine ratio. It will be 41 over 9. Lastly, get the cotangent R by getting the reciprocal of tangent ratio. It will be 9 over 40. So these are the 6 trigonometric ratios. Next example. If tangent theta is equal to 7 over 24, find the remaining trigonometric ratios. Since tangent theta is equal to opposite side over adjacent side, then opposite side has a length of 7 and adjacent side has a length of 24. The missing here is the length of hypotenuse. To get the length of hypotenuse, we will use the Pythagorean theorem that was discussed last quarter. Based on this given formula, what do you think is the appropriate formula to use in getting the length of the hypotenuse? That's right. We will use the formula C is equal to the square root of A squared plus B squared because we are about to get the length of the hypotenuse. As we all know, C is for the hypotenuse while A and B are for the lengths of the triangle. Going back to the formula, the measure of the two legs are 7 and 24 respectively. Substitute, it will be C is equal to the square root of 7 squared plus 24 squared. And we will have C is equal to the square root of 49 plus 576. 49 plus 576 is equal to 625. That's why we have C is equal to the square root of 625. And the positive square root of 625 is equal to 25. Hence, the length of the hypotenuse is 25. Now let's recall. Opposite side measures 7, adjacent side measures 24, and hypotenuse measures 25. The given trigonometric ratio is tangent theta is equal to 7 over 24. Let's get the remaining trigonometric ratio. For sine theta, we have the opposite side over the hypotenuse. It is equal to 7 over 25. For cosine theta, we have adjacent side over hypotenuse. It is equal to 24 over 25. For cosecant theta, get the reciprocal of sine theta ratio, so it will be 25 over 7. For secant theta, get the reciprocal of theta ratio or cosine theta ratio, so it will be 25 over 24. And for cotangent theta, get the reciprocal of tangent ratio, so it will be 24 over 7. These are the remaining trigonometric ratios. Next example. If sine theta is equal to 4 over 7, find the remaining trigonometric ratios. Since sine theta is equal to the length of opposite side over the length of hypotenuse, then opposite side has a length of 4 and hypotenuse has a length of 7. The missing here is the length of adjacent side. To get the length of adjacent side, we will use the Pythagorean theorem. Adjacent side is considered as the leg of the triangle. Therefore, we may use A as equal to the square root of C squared minus B squared. Or B is equal to the square root of C squared minus A squared. Since A and B are the representation for the leg of the triangle. With this example, let's use A is equal to the square root of c squared minus b squared. Substitute 4 as the length of the opposite side and 7 as the length of the hypotenuse to the given formula. It will be A is equal to the square root of 7 squared minus 4 squared. Then A is equal to the square root of 49 minus 16. 49 minus 16 is equal to 33. That is why we have square root of 33. We can simplify this further, so the length of the adjacent side is square root of 33. Now, let's recall. Opposite side measures 4, adjacent side measures square root of 33, and hypotenuse measures 7. The given trigonometric ratio is sine 4 over 7, or sine theta is equal to 4 over 7. Let's get the remaining trigonometric ratio. For cosine theta, we have adjacent side over hypotenuse. It is equal to square root of 33 over 7. For tangent theta, we have opposite side over the length of the adjacent side. It is equal to 4 over square root of 33. Rationalize by multiplying square root of 33 to both sides of the ratio. Then it will be 4 square root of 33 over 33. For cosecant theta, get the reciprocal of sine theta ratio. So it will be 7 over 4. For secant theta, get the reciprocal of cosine theta ratio. So it will be 7 over square root of 33. Rationalize by multiplying square root of 33 to both sides of the ratio. Then it will be 7 square root of 33 over 33. Lastly, for cotangent theta, get the reciprocal of tangent ratio. So it will be square root of 33 over 4. These are the remaining trigonometric ratios. Another problem. In right triangle DOT, BO is equal to 12, OT is equal to 35, and DT is equal to 37. Find the values of the trigonometric ratio sine T, tangent B, and secant T. For better understanding, let's illustrate the given triangle. We have triangle DOT. The measurement of DO is 12. The measurement of OT is 35. And the measurement of DT is 37. Identify the lengths of side with respect to angle T and angle B. Since the questions are finding one of the trigonometric ratio with respect to T and with respect to D. With respect to D, the length of the hypotenuse is 37. The length of opposite side is 35. And the length of adjacent side is 12. With respect to T, the length of hypotenuse is 37. The length of opposite side is 12. And the length of the adjacent side is 35. Using this given lengths with respect to D and T, let's now answer sine T. Sine T is equal to opposite side over hypotenuse. The length of the opposite side is 12 and the length of hypotenuse is 37. Therefore, we have the trigonometric ratio of sine T, which is equal to 12 over 37. Next, find tangent D. Tangent D is equal to opposite side over adjacent side. The length of the opposite side is equal to 35 and the length of adjacent side is 12. Therefore, we have the trigonometric ratio of tangent D, which is equal to 35 over 12. Lastly, find secant t. Secant t is the reciprocal of the cosine ratio. If cosine ratio is equal to adjacent side over hypotenuse, then secant ratio is hypotenuse over adjacent side. The length of the hypotenuse is equal to 37, and the length of the adjacent side is 35. Therefore, we have the trigonometric ratio of secant t, which is equal to 37 over 35. I hope you understand the concept of trigonometric ratios. To wrap it up, the trigonometric ratios are special measurements of a right triangle. The two sides of a right triangle which form the right angle are called the legs, and the third side is called the hypotenuse. The six trigonometric ratios are sine, cosine, tangent, cosecant, secant, and cotangent. If you have queries regarding our topic, you may ask your respective teachers and he or she will discuss it on your follow-up discussion. Moreover, I want you to answer test 1, try this, letters A, B, and C on page 5 to 6 of your ADM to be checked by your class discussion teacher. For our points to ponder, let me share to you this quote from Alan Cohen. The quality of your life is equal to the ratio of appreciation to complaint. Successful people are those who are grateful and appreciate everything that they have. Giving thanks and appreciating what we have always opens the door for more to come. And ungratefulness always closes the door. In this time of pandemic, choose to be grateful with all the blessings you have received. Refrain yourself from complaints because this will only start the feeling of ungratefulness. Moreover, instead of complaining to our predicament nowadays, we can help our community and our nation by following the safety health protocols mandated by the government. Once again, this is Mrs. Charlene Abalos, your live streaming teacher for today. Thank you so much for your participation and time. Happy learning and always stay safe. Bye-bye!